Welcome, everyone. Hi. Welcome to everyone who is in this room, and welcome to everyone who is tuning in online. I hope you've grabbed a coffee, your tea, your energy drink, whatever it is that you need to settle nicely for today's session. Today we're going to be together until 1 p.m. Brussels time. So in case you need to leave early, which is possible, that's absolutely no problem. Just if we can ask you to please hand out your badges and lanyard at the people at the front, that would be really lovely. We're trying to be eco-friendly and we want to reuse them, so please help us out. And thank you for your help already. All right, so today we're going to be talking about cloud security. And as you know, cloud security, it's something that's been on everybody's lips for quite some time, and you might think, why are we talking about it today? Well, this is the second year that the Center for Cybersecurity Belgium and the SANS Institute are partnering to bring about what we believe to be key cybersecurity issues. And we believe it is a key cybersecurity issue because the cloud has changed the way that organizations, whether they're big or they're small, do business, but also the way that states and also individuals handle and manage their digital lives. And so it is not surprising that attackers, but also defenders alike, have taken a keen interest in it. And so it is crucial for us to know how to secure all those resources. And that's why we are bringing this sometimes heavy topic, but the good thing is that we have fantastic speakers who are here to walk you through this. And hopefully by the end of the day, you have key ideas, key trends, key tips that you can keep in mind to secure the cloud. We understand that you want to ask questions. The good thing is that you can. So if you are following online, you have the possibility to do it in the chat. And if you look closely in the chat, you have two sections. And one of them is called Q&A. And so you want to ask those questions in the Q&A part. We'll have moderators who are going to be looking at them, answering those that they can, and the ones that they can't, we're going to be asking them later to the speakers. If you're here together with us in this room, at the end of the presentation, just raise your hand. And we're going to be walking around with microphones, and we're going to hand them out to you. So just raise your hand. It's as easy as this. All right, so to get us started on this topic, but mostly to frame the conversation, I'd like to welcome on the virtual stage, Miguel de Brucker. Miguel, as you've probably met him before, he is a fixture in the cyber community here in Brussels, here in Belgium, but also abroad. He studied at I don't know everything by heart, unfortunately, but I will know his life by heart by the end of the day. He studied at the Royal Military School and the Vrije Universiteit Brussel. He then joined the General Intelligence and Security Service, where he was responsible for the security of classified networks and the creation of the first cybersecurity unit of the Belgian Defense. And mostly I know Miguel because since 2015, we have the great pleasure to have him as our managing director at the CCB.
Thank you very much. Good morning. I'm a little bit waiting for my presentation to pop up. And there it is. Okay, next please. Thank you very much and welcome to our event. Well, we have been moving for almost a decade now, bit by bit to the cloud. Why? Because, well, we do have all those difficult to get and rather expensive IT experts to secure our own environments, to implement everything in the correct way on-prem, and that remains a difficult task. So we moved to the cloud, and then we are much more secure, and we don't really need all that expertise in-house, right? So your access control is well managed, the network and the environment is completely monitored. Everything is backed up, and if you need incident response, you have the cloud providers to do that. Updates, they're all organized. All the legal aspects, GDPR, it's all in the contract. Even sovereignty requirements, you exactly know where your data is, right? And of course, you have multi-factor authentication on all your connections. So the cloud is really a security dream, isn't it? Well, next. If we look at, oh, now I can see there. If you look at a few key findings, well, more than 50% of all malware is coming through the cloud. And the number of vulnerabilities and exposures last year doubled in the cloud. And if we look at, well, all those experts that we don't need anymore, let's be honest, the human error is still the leading cause and leading factor in security breaches in the cloud. And linked to that, misconfigurations contribute significantly to what is going wrong. If you look at the organizations, only 4% believes their cloud data is fully secured. And as a last key finding, I loved and I hope my maths are still correct, but by 2025, we'll have more or less 200 zettabytes of data. That is half of world's data will be in the cloud. That is a 2 with 23 zeros after it. So that's an enormous amount. Next. So that's why I think this conference is so interesting. And where should we then start? And Clara was saying, well, we hope you have some ideas at the end of the day. And let me start with something very, very simple. If you have to start securing your environment, next, maybe you should start with MFA. Make sure that you have multi-factor authentication, please, even in your cloud environment. So I hope you can enjoy this conference. Thank you very much for being present, and I hope to get positive or whatever feedback afterwards. Thank you very much.
I think we definitely have some interesting fun facts and data, which is why we think that now it is important to actually bring in our main speaker, our lead speaker, who is Frank Kim. Frank is a SANS fellow, where he leads the cloud security and cybersecurity leadership curricula. But he's also had many lives, and previously he led various CCB positions. And he, on top of this, continues to serve as an advisor to security startups, and is also an author and a teacher of multiple courses at SANS. So for anything cloud related, Frank is your guy, so welcome, Frank.
Thank you very much, appreciate it. All right, good morning. Hello, everybody. Nice to see you all here in person. I believe that there are a lot of online participants as well, so hello to everybody online. We're going to talk about, in this first presentation here, well, 5 different topics, 5 key trends that we've seen here at SANS. And in the last handful of years at SANS, we've talked to lots of organizations, institutions, customers, various companies, and some common themes have emerged. And we're going to highlight what those are and give you some examples, sometimes some detailed examples here over the next hour or so related to what those trends are that many organizations are dealing with, have some challenges with as well. Now, thank you, Clara, for the nice introduction. Just real quick here. The clicker is not working. Now, in terms of the quick introduction, I've been teaching and writing classes with SANS for 17 years now, and along those 17 years, I had different day jobs along the way. And I was the CISO at SANS for a little bit. Most recently, I was the CISO in residence at a venture capital firm where we invest in different cybersecurity companies. And a key trend amongst the different startups that have been doing things, of course, well, now is Gen AI, but more recent, before that, it was cloud. Every single cybersecurity company was trying to do something in the cloud itself. So in terms of the topics here, now I apologize, this is going to be a little bit of an eye chart for the folks at the back, so I'll walk through this here, and I think everybody online will be able to see this. But these are the results from a history of various Goldman Sachs CIO surveys. And over time, it's been shown that, hey, in 2016, enterprise cloud adoption was approximately 10% of various workloads. Well, when did it actually hit 20%? Now, in the post-pandemic boom, cloud adoption, especially for enterprise workloads, increased by a large amount, but it still only hit approximately 20% of enterprise workloads in the cloud. Today, fast forward to mid-year 2024, well, the survey points out that approximately 30% of enterprise workloads have been moved to the cloud. Is that a lot? Or is that a little? Well, it depends how you think about it. The growth has been extremely huge, but when was the pop quiz, everybody? And I apologize to everybody online. I can't see any responses that you might be saying, but does anybody know when the first cloud service, roughly how many years ago was it released? I heard some whispers here. 20. I heard 20, 15. Right? Well, so I can't see who said that, but yes, 20 years ago, AWS released their first publicly cloud service. A lot of times we think it's EC2, but it was not. It was STS, right? Security SQ messaging service. And so in 20 years, right, only about 30% of enterprise workloads are in the cloud. Andy Jassy, the CEO of Amazon, not too long ago, said that, hey, from the data he has, 85% of IT workloads are still in traditional on-premise environments. So this means, as kind of like Miguel was saying earlier, there's a huge runway for cloud adoption. We are still in the very early innings. And as the black line here shows on the far right-hand side, it's forecast that in about 3 or 4 years, enterprise cloud adoption is going to increase to 40+%. Right? So roughly every 3 or 4 years, historically, we've seen about 10% growth. So there's a lot for us from a security perspective. What does it mean? Well, it means that we've got to continue to get ready and knowledgeable about all of the different details of cloud security. And as I mentioned here at the beginning, well, 5 themes constantly come up when we talk to various people, organizations, companies, and so on. So the 5 topics, themes that we're going to talk about today are, number 1, identity. I think we've all heard the saying, right? Identity's the new perimeter. And there's a reason for that. It's not that the old perimeter is necessarily going away, but now with SaaS services, SaaS applications, how the cloud itself works, as we're going to see here with one example, right? It's a big focus on identity and securing that particular perimeter, but it's also a problem related to how do we design it right from the start. Long time ago, this is total tangent, just popped into my head, but my wife and I have done a lot of home remodeling over the years. And in the first home that we remodeled, we did 70% of the work ourselves, but we did not hire an architect. And so we kind of put it together ourselves. And if we hired an architect, though, well, the architect probably would have said, it's not such a good idea to have in the same home, in the same visible area, redwood and maple and Douglas fir all in the same place. Right? Not very consistent. And it's fine, it looks good, but it was okay. And this is how a lot of enterprise technology environments, enterprise IT environments get built up. A little bit here first, oh, let's do something else, a little bit here, right? And that's also how a lot of cloud environments have come up. Years ago, when I first started moving to the cloud, workloads to the cloud, I participated in a couple of relatively large lift and shift initiatives. And when we lifted the servers, the software, the workloads from the traditional on-premise environment and put them into the cloud, did everything work? I see some shaking heads no, but I mean, it worked. We got it to work, right, by forcing it through, but it wasn't done appropriately, optimally, taking advantage of various cloud-native approaches. And one of those cloud-native approaches is, in the middle here, automation. As we'll see a couple examples here and later on this afternoon, well, taking advantage of that automation with infrastructure as code, with using an API-driven approach, right? Using cloud-first services, that's how we can best take advantage of the move to the cloud versus just that traditional lift and shift. But when you move things to the cloud, your work is not done. You still have to constantly assess. Miguel showed some statistics. He mentioned one of the big problems is misconfigurations, misuse of the cloud itself. Now, I believe that cloud can be just as secure, if not more secure, than what we do in our traditional on-premise environments, but you've got to do it appropriately. How do you figure out if it's appropriate? Constant assessment. And then finally, right, naturally, hey, some bad things are going to occur. We will see an example of a cloud security incident, a breach here momentarily, but that's why we've got to constantly detect, right? What is it the adversary, what is it the bad guy is actually doing? So as a result, right, we're going to start off with a well-known cloud security breach. Quick show of hands, who has heard of the Capital One breach? All right, maybe 25% of hands go up, 30% of hands go up. So to set the stage here, right, Capital One of the leading financial institutions in the, that is cloud first, right? They have moved all of their infrastructure over to the cloud, AWS in particular, many, many years ago. They've created various open source security projects. Cloud Custodian, Hygieia contributed those to the community. But even the most advanced organizations can have some issues that arise. But what was interesting about this breach was not that a lot of data was lost, 106 million records. There's been bigger breaches before, smaller breaches, and so on. What was interesting was, as you see from this screenshot, there was a detailed FBI arrest affidavit that occurred when the breach was publicized, when the breach was publicly made, taking the person into custody, Paige Thompson, the perpetrator, right? Now, it turns out the FBI agents who wrote this arrest affidavit, they had some technical knowledge, as we can tell from reading the 30-page document. There was enough technical details in there that showed, well, hey, how did this attack, right? How did the data actually get stolen? And that's what was interesting about it, a formal, written, official document describing in some level of detail what actually occurred. Now, does anybody know how Capital One was discovered, this particular breach? Did they detect it with their automated tools and detection, the incident response team, the SOC team? No, somebody found the data on the web. And they saw it because Paige Thompson was bragging, right? She said, oh, here's some data, by the way. Hey, do you know where this is from? Somebody saw it and looked at it and said, this looks like Capital One data. And they told Capital One, and then they investigated and said, yes, this is actually our data. 106 million records. All right, now we're gonna get into some details here. Let's start at the high level. Now, in AWS or any cloud provider, right, you need to deploy various infrastructures to then deploy your servers, to then deploy your application on top of those servers. In AWS, you deploy the big outer box here inside of your VPC, your virtual private cloud. Inside of your VPC, you've got your traditional networking approaches, right, that you define, right, like in your traditional environment, but you define it in a different way. You define your subnets, your internal, your public, private subnets, and so on. Inside that subnet, you've got the little orange box, your cloud VM, your cloud server. In AWS parlance, your EC2 Elastic Compute Cloud Server. That's on top of where you deploy your application. Now, you all have some online banking account access that you probably use on a regular basis. When you go in and log into mybank.com, one of the things that you want to do is maybe look at your monthly statement, right? To see what's going on. Well, that monthly statement, the PDF, under the hood, where is that stored? Where is that PDF document stored? Well, in this example application, the PDF document is stored in your storage, right? Your storage bucket. In Amazon, that's your S3 simple storage bucket, right? And then the application gets that PDF from that storage bucket and displays it back to you, the user, right? Basic stuff. The problem is, though, does the application have the appropriate permission to access the storage bucket? How do you tell it what permission to use? That's where the stuff on the right-hand side of the slide comes into play. Sometimes, automatically, we'll talk about these details here, you've got IAM, Identity and Access Management. That's a big topic, even in one cloud provider. But there's a feature of IAM called STS, Security Token Service, right? That allows you to get some temporary credentials back to the cloud VM, back to the server, and that those temporary credentials are used to give the application the ability to read the S3 bucket and serve up your PDF monthly statement. All right? Make sense? That's your common application architecture at kind of a high level here, right, in the cloud. So that was the situation that Capital One had. Now, a little bit more details. How did Paige Thompson start to steal all of this data? There's an issue, a bug, a vulnerability. The folks at Capital One had made a mistake, just like many organizations do, where they had a vulnerability in their web application at their CapitalOne.com called SSRF, Server-Side Request Forgery, right? You don't have to remember that acronym. The main thing here is that if you've got a URL request in the browser bar, you normally type something like mybank.com. You got a normal request like this. But at the bottom, Paige Thompson sent in some arbitrary, some malicious, some unexpected data. Notice there's an IP address down here at the bottom. Hopefully you can see this from the back. 169.254, 169.254. Mentally bookmark that here for the next few slides, because we're going to come back to that. That IP address is very important. Does anybody know what that is? That? Say that again? That's right. That is as Chris just mentioned, that is a private IP address. That is not publicly routable. So what is the attacker doing there, right? Why are they calling a private IP address? Just remember those numbers just for a few moments. Because here on the next slide, it turns out that that IP address represents the instance metadata service in AWS. The instance metadata service is what provides those temporary credentials back to the application to get your PDFs that I was mentioning. All right? Now, when you call that instance metadata service, that could, as Chris said, should only happen internally to AWS, meaning that normally it's the server, the cloud VM, that under the hood is calling that IP address, the instance metadata service, and then retrieving the temporary credentials down here at the bottom to access the storage where your PDFs actually are. Make sense? All right. Now the problem though is, remember, this all started because Paige Thompson found a bug, a vulnerability in the web application that allowed her to pass in at the URL, like this at the top, that then would send back through the browser the credentials back to wherever Paige Thompson was in the world. Singapore, London, New York, right? Brussels. And then she gets those credentials, and now she has access using those credentials as if she is the AWS server, the cloud VM itself. All right? So once she gets those credentials, what does she do? All she does is she copies them over, types AWS configure on her computer, on her terminal, command line, and gets now access as the VM. Wow, interesting, right? And so she does that, configures her client, and then she enters a simple command like AWS S3 sync, and she downloads all 106 million records containing all of the credit card applicants and their personal info. All right. So, whose fault was this? Is this Capital One's fault? Quick show of hands. Oh, maybe 10, 15%. Is this AWS's fault? All right, fewer hands, right? So there's that whole concept of a shared responsibility model. And so, well, let's talk about this. Let's see what this means. So I mentioned the 5 different trends. So we talk about the Capital One breach to set the stage here for identity. Now, identity is a huge topic. So in the limited time that we have, we can't cover everything. So we're going to talk about one thing related to identity, which is related to that 169.254 that we just mentioned. That instance metadata service, right, providing you temporary credentials. Every cloud provider has the exact same functionality, internally even using the same IP address, right? Because it is so convenient. That functionality to provide those temporary credentials, actually that's a big benefit, a big security benefit actually even. In the olden days, I wrote insecure applications and systems and code where we would even worst case hard code the credentials. That's not so good, right? But each of the cloud providers, they call the same service by different names, whether it be an instance profile via the instance metadata service, the managed identity in Azure, or more simply named the service account. All the exact same functionality in all the 3 cloud providers. Now, there's one thing that I didn't mention. You might have noticed it when I said, keep in mind that IP address at the very end of the URL, at the very end of the request, the URI, there was something called the bad WAF role that I had on the slides. Now, why did I put that there? Well, that actually comes almost directly from the FBI arrest affidavit. In the arrest affidavit, they kind of obfuscated it. They said star, 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 WAF role, right? And they said, hey, there was something about the permissions, overly broad permissions, that allowed the attacker to then steal the credentials and then download all 106 million records. So here, I've just called it bad WAF role to make it obvious what it is. And so when you send that in with the specific not just the IP address, but the extra stuff at the end of the URI, IAM/security, credentials/bad WAF role, then, as we saw earlier, you get back the corresponding credentials, and then the attacker uses that to download all of the documents. But why? It wasn't just because there was a bad issue, the SSRF, in the web application itself. There was also a misconfiguration, an example of what Miguel mentioned earlier, right? And this is now a commonly understood one after the attack. But notice, usually, you guys know where the problem is, we're pointing to it, whenever there is a star in a security-related configuration, most of the time, not every single time, but the vast majority of the time, it means that there's usually a problem. So here, the corresponding permissions that were attached to those credentials on the prior slide looked something like this, that allowed list and get actions on the S3 bucket, but which S3 bucket? Down here at the bottom, here's the problem, star, on every S3 bucket. That was the problem that allowed the attacker to download all of those 106 million records and corresponding documents. So this is, again, a common example of, hey, we need to make sure that we understand the details of the cloud, your security teams do, to be able to secure it appropriately. Now, side note here, Azure, as I said, other clouds do the exact same thing, but the details are a little bit different. As you can see here at the top, it's still using that same internal IP address, right, to use their managed profile, managed identity, but they're also, right, notice there's some differences in how the credentials look. This is because under the hood, right, Azure uses a JWT, a JOT token, a JSON web token to provide the corresponding access. And you can see here that the second line from the top, Azure's is a little different because it's explicitly, this token is explicitly scoped to that particular service, storage.azure.com. All right, so this is just to show that, hey, another example, this is how it works in Azure, basically the same thing. What was another important part of this? Well, it turns out, oh, let me go back one slide. Line number 3, there's this -H for header, metadata true. It turns out when the Capital One attack happened, in the years before that, there was various security researchers that actually said, hey, AWS, your instance metadata service is not as secure as the other cloud providers, right? Because you're not basically doing that metadata true. You're not passing a header to mitigate SSRF vulnerabilities, right? Because the SSRF vulnerability allowed the Paige Thompson to type in 169.254, right, and get the credentials back to her. But if at the time you happen to be using Azure or Google Cloud appropriately, right, there would have been, if you did it right, some level of SSRF mitigation, right? But AWS at the time did not have that option in place. 6 months after the attack, what happened? They introduced the Instance Metadata Service, IMDS, version 2. Version 2, which did mitigate, right? Which does mitigate this by passing in some extra data. Not just a header, but they went a little bit farther. They required the temporary token request to be authenticated, all right, which is good. Now, it's been some number of years since this all occurred, approximately 5 years. It's only now that the Instance Metadata Service version 2 is the default approach, right? So as we can see, I think you know, in traditional on-premise environments, it could take years, right, to deploy something, to change something. Even in the cloud, depending on the details, right, the runway to switch from one approach configuration to another could take some time and planning as well. I'll just mention one other thing here because there's other protections that you can use to mitigate, right, this particular attack. On the far right-hand side, AWS is the only one that has a prevents extraction feature. Technical pop quiz here. What is the networking header that prevents packets from being routed indefinitely on the internet? Yeah, I heard it. TTL, time to live, right? Time to live is when a packet goes from router to router, the TTL decrements by 1. When it gets down to 0, right, it'll be discarded by the router itself. AWS did something clever. They set the TTL of the packet containing the credentials to 1. So that if it goes from the internal IMDS server back to the cloud VM that's requesting it, then it shouldn't be able to be transferred on the network any more than that. Right? Just an interesting small detail. So that was one example of identity, right, and how foundational this is to the cloud. And so, yeah, Miguel mentioned MFA, right? Of course, yes, we need MFA. Now the cloud providers to access via API are having MFA now going forward, in many cases, enabled by default, right? Even for non-regular users. This is a good thing, but it takes some time to get there, right? Hardening these type of things is another, right, example of what we need to think about from an overall cloud perspective. So, number 2, architecture. All right, as I mentioned, I was involved in a couple lift and shift initiatives. But when we move to the cloud, what is well, just like when we talk about the bank, right? Maybe you've got numerous accounts at your financial institution. You've got a checking account, a savings account, a brokerage account, maybe from different institutions. And those accounts, right, have their own blast radius. Right? You can transfer money between some of those accounts, but they're intended to be somewhat conceptually separate, right? Similarly, in the cloud, well, what is the blast radius, right? Well, it's the stuff that is in your account is constrained to that particular account. And that's originally how things came up with AWS. But there's a problem. If you're a large organization, how many accounts, let's say AWS accounts, do you have in your environment? What is your guess? What is the range of accounts that you have? 1, 10, 20? 20 per person. Well, that's a lot of people. Yeah, that's possible, right, within IT. Well, of course, it depends on, yes, the size of your organization, the footprint, the number of services, the number of applications that you want. But if you're a large organization, you've got hundreds, thousands, right? Sometimes tens of thousands of accounts. Imagine if you had 1,000 checking accounts. That's kind of conceptually the equivalent. You will never be able to manage that. And that's actually what occurred in many organizations that first started moving to the cloud some years ago. You had thousands of different accounts. It became unmanageable. And as a result, what did the cloud providers do? Well, AWS, on the left-hand side, specifically said, yeah, we've got to help our customers get a better handle on this. It's too much administrative overhead. So they said they introduced a service called AWS Organizations. And AWS Organizations, here on the left, introduced a hierarchy where you've got a root manage account, also known as the payer account, because that's the one that ultimately pays the bills, but then allowed you to define different organizational units, HR, finance, business unit 1, 2, 3, and so on, that then various accounts are rolled up into, and in those accounts, this is where you deploy your various services, S3, EC2 servers, and so on. All right? So very useful hierarchy. We're talking about this here because for you, from a security perspective, now you may have input into this, work with your cloud engineering teams, work with your operations teams on this, but the main thing is to first think about the structure, the organizational structure of the corresponding accounts. Google has a very similar structure on the right-hand side, basically the same thing, but they call the equivalent of the account in Google is what they refer to as a project, right? Conceptually similar, conceptually the same thing. In the middle, Azure. Azure's equivalent of an account, right, is what they refer to as the subscription. But as you can see, Azure has 5 different layers, 1 extra layer. Now, you got still the root management group, the top-level management group subscription, but they also have resource groups, the second slice from the bottom in the middle. To be honest, I wish all the cloud providers had that because it's very convenient. And it's easier, right, to define a permission at the top level. If you do, then that cascades all the way on down. So then, if you have resource groups for HR, finance, business unit 1, 2, 3, you can define resource groups for those corresponding resources and make it easier to cascade permissions or manage those particular resources. But we mentioned this high-level organizational structure because all of the cloud providers also have a way for you to enforce some controls. AWS Organizations comes with a feature called SCPs, Service Control Policies. This is actually a key thing for you, your security teams, to become more knowledgeable, versed in, because what you're going to do is you're going to define things like a landing zone, right, that has certain SCPs, service control policy rules, built in about what is not allowed to be done in your cloud environment. For example, you might specifically say, we do not want to allow workloads to be deployed to Japan, because maybe you don't do business in Japan, or maybe you do. We don't want to allow some expensive resources to be deployed, right? Like an HSM, right? A hardware security module that is a little bit more expensive. So you can specifically, right, limit, restrict. Now, this is not allowing. This is only restricting stuff, which is traditionally what we like to do in security. Google, on the far right-hand side, the organizational policy, is very similar, right, to what AWS does. But Microsoft in the middle, it's a little bit more robust with their Azure policy here, because you can not only audit, see what's going on, what people are trying to do that they shouldn't, but you could, after being in discovery mode for some time, you can also enable it in remediation mode. This server, right, has been deployed without all of our requirements. Let's go ahead and automatically change it. Right? Now you've got to do some testing and do all of that stuff before, but the possibility is there. Oh, somehow a server got spun up in a region that wasn't allowed. Okay, let's go ahead and get that deprovisioned. Right? So a number of things that you can do with either SCPs, Azure policy, or organizational policy. Now, talking about AWS in particular, how is this set up? Well, AWS is got your account, right? But when you log into your account, you can deploy stuff in any region, as long as you don't have a restriction in place. As we know, there's different regions around the world, US East 1, EU West 1, AP Northeast 1, and so on in different continents. But within each region, right, you've got different availability zones. In AWS parlance, an availability zone is not just one data center, but a collection of data centers that are then connected to each other via the dark lines, high-speed links. All right, notice that across the regions, though, there's no lines. How do you transfer data from one region to another? Well, you've got to do it, well, encrypted, of course, maybe over the public internet, right? Or you'd have to set up some sort of direct connection, right, between the regions. AWS has services for this as well. All right. Now, in your traditional network architecture diagrams, right, you're going to have things like what? Firewalls, routers, switches, traditional application diagrams, architecture diagrams. You're going to have your application server, your web server, your database server, and so on. Usually, what happens in those traditional architecture diagrams is you add in the security controls, right? You add in, here's some encryption, here's some authentication. The cloud kind of reverses that. As an example, AWS's security reference architecture, right, specifically says, hey, look, you've got to think about your organizational structure that we were saying. The commonly suggested best practice architecture organizational structure is to have not only your root org management account, but you're going to have conceptually 3 different types of organizations. Your security org on the left, your infrastructure org in the middle, that contains your networking rules, your firewall rules on the far right-hand side, and your workloads, your application accounts. Now, in real life, this is the conceptual architecture diagram. You're going to have multiple, right, infrastructure orgs. You're going to have multiple workload orgs, right? Why? Because you've got multiple workloads, applications in your environment across your organizations. But conceptually, this is the same blueprint that you, from a security perspective, want to make sure is in place. If we zoom into the security organization, in the security org, right, you're going to potentially, I should say, potentially use any number of these services. Now, on the slide here, we've put in a lot of the commonly used AWS security-related services, like Security Hub, like GuardDuty for threat detection, which we will see an example of at the very end of this presentation. Macie, if you do DLP. Now, this is just for reference. I'm not suggesting go use all of these services, right? But these are examples of the type of capability that you want to have enabled for your cloud environments. And then, of course, you've got your log management account on the right-hand side. You probably already have a centralized SIM, right? But you're still going to want to store your cloud-based logs, your CloudTrail logs, and so on that are automatically generated via any AWS activity into a central log archive account that is, yes, as we know, read-only. All right. Let me pause for a moment. Any questions so far? So we have talked about two of the topics. First is identity. Talked a bit about architecture, structuring things appropriately. So now let's go ahead and move on and talk about automation. Who here, show of hands, has heard the analogy cattle versus pets? Oh, interesting. Very few hands actually go up. Interesting. Maybe online, some of you have heard cattle versus pets. Now, you know, this might be a little bit of a harsh example here, but I didn't make this up, right? So, but this is the common, for years now, the common industry way to talk about this concept. And in the olden days, before the cloud, when you had to stand up a new server in your data center, you've got, let's say, a Windows server. You've got some administrator that has to go in, download Windows, install it on a machine, then go click next, 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 and configure all of the things in Windows, right? Well, who was the person that was knowledgeable about all of the configurations on that server? Well, yeah, that administrator, that particular person, and maybe his or her colleagues. But it was a small set of people that knew about those configurations. And as a result, that person, that team, had to give a lot of care and love and feeding to those particular servers, because they were all unique configurations. And so as a result, we gave our servers, at least I did back in the past, unique names. Husker, Boomer, Apollo, Starbuck, and so on, right? Because we had to give them all love and care and feeding. And we treated those servers like pets. We treated them like pets. And there was a lot of pets in our data centers. But now, with the move to cloud, what we want to do is we don't want to treat our systems like pets. We want to treat them, well, yeah, sadly, like cattle. Because if cattle get sick, what do? Well, we get rid of that cattle, and then we move on and get another one. And the cow doesn't have a name. It's got a serial number, right? So that is the concept, right, of how do we start to automate some of this infrastructure in our environments. Does this mean that we're not going to have pets in our environment? No, we're still going to have some pets. Just like in the real world, many households, many of us have pets, cats and dogs at home. There's still going to be pets, but we want to, especially from a security and operations perspective, minimize the number of pets in our environments. There are some systems that are more important than others. Your domain controller, your main build server, your CI/CD server, whatever it might be, and those might be more akin to various pets. And if you have a pet, you ideally don't want a household full of 100 pets. You want a smaller number of pets so you can pay more attention to them. All right? So how do you go about having a pet? This is an example of some AWS CloudFormation code. All right? Now, if you haven't used CloudFormation before, that's okay. I'll just highlight a few things here. In the olden days, we had to get our hardware bought, purchased, procured, wait for it to be racked and stacked in the data center, right? Get the power and cabling to it and all of that stuff. And it could take, in some environments I've been in, months, 6 months or more to get a new server deployed. Very slow. In the cloud, as we know, all you actually have to do is write some code like this. Or you could go to the console and click next, next, next. But we recommend you take the code-based approach from an automation perspective. So line number 2, we're saying we want to create a new EC2 instance, a cloud VM, the orange box that we saw before. We want to, line number 5, assign some permissions to it, like the permissions to download your PDFs. Then, line number 8, we've got the secret key that if you want to SSH, remotely connect into the server, that is the corresponding key, right, that you would use, the corresponding key pair. Line number 9 and 10, you've got your security groups in AWS. That's your stateful firewall, right? So you would define what your stateful firewall rules are associated with this particular server. And then, right, what subnet, what part of the network is it deployed in on line number 11? And then you can have some optional commands down below. There is one, does anybody happen to know? There is one configuration here, right? You just type AWS CloudFormation deploy this, and it'll get deployed. But there's one configuration that you probably don't want to have in the modern world. Does anybody happen to know what that might be? It's a little bit of a deep cut here question. What line number do you not want to have on here? Because in the cloud world, ideally, servers, because they're cattle, not pets, should be immutable, right? Meaning, once they're deployed, hey, you don't change it. If you need to change something in the server, what do? You change the code, you deploy the new version of the server with the updated code, and then you tear down the old one, right? And this happens all the time. We usually in the cloud don't always have long-running instances. We've got shorter-lived servers. So as a result, line number 8, you probably don't want in your configuration, right? Because you don't want the administrator remotely logging into the server. If something needs to be changed, where do you change it? In the code, right? You change it here in the code and then redeploy the code, redeploy the new VM. Make sense? All right. Now, talking about automation. Now, it's not going to be the admin that is at the console typing AWS CloudFormation deploy, right? What they're going to do is they're going to use a tool like one of these CI, continuous integration, CD, continuous delivery tools. The most classic traditional one that has been used for a long time, especially in on-premise environments, is in the lower left-hand corner, Jenkins. But now there is a huge move to cloud-native CI/CD tools that automate the deployment of your code, application, and infrastructure code, like GitHub from Microsoft, GitHub Actions, like GitLab CI/CD. Now, Microsoft is a little confusing because they own 2 of the leading solutions. They own both GitHub and they own Azure DevOps. But we've used both, but it appears that industry-wide, which one has more traction? I think I heard it. Yes, GitHub. GitHub has more industry traction. So if you're starting from scratch, if you're going to pick one, I would choose GitHub, if you're choosing from the Microsoft products. All right. Now, we talk about these tools, examples of tools, because the backbone of the CI/CD process, what we're talking about here is DevOps, right? DevOps is how you roll out this automation across your organization. We'll talk in more detail, see some examples of some other DevOps-related things later on in this session overall. But this process is the backbone of what we do from a DevOps and CI/CD perspective in terms of pre-commit. Before your developer, your engineer types in at the command line git commit and git push, right, to send up some code, all of that stuff, before they type those 2 commands, that's the pre-commit phase. Once the code is actually committed, it goes up to your version control repository, GitHub, GitLab, and then the commit phase gets kicked off, automatically kicking off your CI, continuous integration, to automatically build the code, build the application, and then it automatically packages up and then deploys it. Continuous delivery to different environments, like the acceptance environment where you run some tests, and then eventually to the production environment for continuous operations. Now, why do we mention this seemingly common basic process? It's because for us in security, at every single one of these phases, we want to add various security activities across the entire life cycle of this process. Now, I won't go into all of these here, right? But on the far left-hand side with pre-commit, you've got some pre-commit hooks. I mentioned the developers, the engineers typing git commit and git push. Has there ever been a situation where an engineer or somebody accidentally saves a token, a credential, an authentication value to the source code repository? Yes, of course, right? Yes, it happens all the time. Now, the problem with that happening with Git is that anybody who downloads, does a Git clone and downloads that code, well, now that credential is everywhere. So it's not enough to just delete it from your version control repository. You've got to, well, ideally delete it and change it. But wouldn't it be nice to prevent this from the beginning? What if, before they type git commit and git push, there was a way to detect that there was a credential or token or something sensitive that was being saved? That's exactly what you do with your lower left-hand corner here, your pre-commit hooks. Right? So hopefully, part of your process, you're going to define various pre-commit hooks across your environment so that you minimize the chance that somebody's going to do this. In the commit phase, this is where you'll do some things like SAST, static application security testing, static code analysis, to do some basic checks. Now, these checks have to run fast because this entire pipeline you don't want to slow it down, right? You can't slow it down too much. Then in the acceptance phase, as one example, you're going to do some dynamic tests because that's where the application is packaged and running, deployed somewhere. So you're going to have some basic dynamic tests that are run against the app. And then in production, right, there's a number of other things that you can do in terms of managing your secrets correctly, the corresponding authentication tokens, and then various things to do in the operations side from a continuous detection perspective as well. So what's an example of this? I mentioned Jenkins is the most classic tool that has historically been used the most. As a result, we've got an example of what a Jenkins pipeline might look like. Pre-commit is everything before, on the far left, before this gets kicked off. The CI, the commit phase, once you check in the code, the build process starts, where then you then run some additional potential tests and then eventually deploy it. Basically, under the hood, it's running that AWS CloudFormation deploy, but in an automated way. But it's not just the deployment that happens automated. Here on the next slide, right, we can see that, hey, all of the tests could potentially happen on an ongoing basis as well. Here we've got an example of the CFN NAG tool, right, free open source tool that has been integrated with this particular pipeline to run on a regular basis. And in this case, in our test infrastructure, it only found four related issues, 4 vulnerabilities, 4 misconfigurations, I should say, at the top. And then you could go ahead, double click on that and drill down into what those 4 detailed specific items actually are. All right, now there is a problem here. There's a challenge. Well, I'll call my friend out. Some years ago, I was having, maybe some of you have heard me mention this before. I was having a beer with one of my friends. He's also a security person, been in security for a long time. He's a security expert. We're having a beer together, and halfway through his second pint, he slowly starts to put down his beer. And I know him, so I could tell he was going to say something that he thought was deep. And so then he puts his glass down, it hits the table, he says, "Frank, I finally realized why I hate DevOps. I hate DevOps because it's just another excuse for developers to have root administrative access in production." Yeah. Well, I didn't say anything. You know, we were having a good time, so I didn't want to argue with him. The funny thing is, 6 months later, he got a job at a fintech company leading, right, the security team at a cloud-first and DevOps-first organization. So within 6 short months, he did a complete 180, right? So, but when I was having a beer with him, it's because he didn't fully understand how the CI/CD process and the tooling actually worked, right? It's not that the engineer has root access in production. The fear was the engineer could push something, git commit, git push, and something bad might go to production. But that's not always the case because there is a difference in CD. There's a difference between continuous delivery and continuous deployment, right? Continuous delivery at the top here is when you, the organization, the business, not us in security, but the business decides when do we want to deploy a new release. And the technology allows you to potentially be ready to deploy at any time. But in the upper right-hand corner, somebody pushes the proverbial button, right? But you're waiting. You're waiting to push the proverbial button. At the bottom here, continuous deployment, that's when the change, git commit, git push, that's when the change automatically goes to production. So what does that mean? Now, you could, in a highly regulated environment, always do continuous delivery. But even in a highly regulated environment where you've got to follow ITIL infrastructure, IT infrastructure library processes, you've got a CAB, a change advisory board, you might still decide that certain changes are going to be pre-approved. Maybe certain basic changes, basic bug fixes, text changes, whatever it might be. So you get rid of all of that mundane work and automatically push those, right? But then the more important things, changes to your security functionality, PII-related systems, cardholder processing, whatever it might be, then maybe those have to go through continuous delivery. All right? All right, so that brings us to number 4 out of 5 here, which is assessment. Now, there's all this stuff we've now moved into the cloud, our infrastructure, our applications, the corresponding configurations and settings. The problem is that we've got to figure out, well, is it done appropriately? How do we know? Well, one way is that we can follow some industry best practice benchmarks, like from CIS. Right? The Center for Internet Security on their website has dozens of different benchmarks published over the years for things, yes, I think as you know, like Windows, Linux, and so on. But they've also got benchmarks now for all of the cloud providers, AWS, Azure, Google, and others. So what's going to happen? If you download this benchmark PDF, best practice configuration, and you turn everything on, what's going to happen? If you did that to your Windows server, what would happen to your Windows server? Nothing works. Yes, we speak from firsthand experience. Nothing works because the settings are too strict, right? So then why? Why would you use these CIS benchmarks? You use them as a starting point. Because when the auditor comes in, right, the auditor is going to say, well, hey, so how did you come up with these configurations? And you can't just say, well, I made it up based on my awesome years of experience, right? I just know this is what needs to be done. What you want to say is, I started with an industry standard benchmark, and based upon our needs, our requirements, our business requirements, we had to adjust the industry standard to turn the benchmark into our internal baseline. All right? So that's why you start with these various public ones. But there's a catch. Now, does the cloud move fast or slow? Simple question. The cloud moves fast, yes. So every single seemingly day, week, right, there are changes to the various cloud services. It's pretty much guaranteed that in your orgs, there's some engineering team that is using some cloud service that you didn't know about last year. All right? So as a result, we see that too with the benchmarks. They're a little bit lagging. So they cover common areas like identity, logging and monitoring, and so on. But they don't cover all of the services that you might be using within your organizations. So from a security perspective, you got to know that the benchmarks are not necessarily entirely comprehensive, like they more so are with Windows and Linux, because those are long-established technologies, right? Not changing as much. So how do you go about keeping up, and how do you go about automating some of this? Well, there are various cloud security-related tools. There's 3 categories of tools that we most commonly see in the cloud space now. Now, whether they be commercial tools, or there are some open source variations of some of these tools. Specifically, you've got the CSPM, Cloud Security Posture Management. Has anybody used one of these before? All right, a handful of folks. Now, the CSPM, it's kind of like in the traditional environment. You got your vulnerability scanners, right? There's some open source, free ones, I should say, but the commercial ones from Tenable, Rapid7, Qualys, and so on, right? The main 3 vendors. It's kind of required that we have some sort of vulnerability scanner. It's getting to the point that if you have a lot of stuff in the cloud, for public cloud infrastructure and platform services, you pretty much have to have some form of CSPM. That is your cloud-based infrastructure scanner, right? That is looking at, well, the right settings, are you doing the right thing, are there any gaps, and so on. So that's for anything deployed in AWS, Azure, or Google Cloud, primarily. In the middle here, we've got something called CWPP. Now, there's another confusing term here that we haven't talked about yet. There's this category of tools called cloud-native solutions. Cloud-native solutions are technologies that are not cloud vendor-specific, but that allow you to take advantage of automation, API-driven approach like containers, Docker, Kubernetes, and other related API technologies. To secure those container-specific workloads, well, the best practice suggestion is to look at some form of CWPP, Cloud Workload Protection Platform. All right? And then finally, another thing we haven't talked about in cloud because it's such a broad topic is your SaaS, Software as a Service applications, like your Google Workspace, your Microsoft 365, your Salesforce, your ServiceNow, right? Those SaaS-based services, well, how do you protect those? That's where the final category on the right-hand side, your CASB, your Cloud Access Security Broker, comes into play. The CASB, along with a newer acronym, SSPM, SaaS Security Posture Management, is intended to give you visibility into, right, the SaaS applications. All right? So from a visual perspective, I think we know, hey, that the modern architecture has changed. It's not just the hard, crunchy exterior anymore with your network perimeter, as is evidenced perhaps by the lower left-hand corner around 7 o'clock, your legacy data center, right? But the perimeter has been expanded, right, to encompass not only your cloud infrastructure platform, AWS, Azure, Google, but also all your other SaaS applications. So in terms of the tools, just to highlight this, the CSPMs specifically are for your infrastructure and platform providers. Your CWPP, right, that's for any place you run cloud native workloads, which could be in the cloud or it could be on-prem as well, that you call your private cloud, right? And then your SaaS-based solutions, right? The intent is that the CASB will be the ones that are applicable to your SaaS-based solutions. Now there's a catch though, right? One of the biggest security vendors is Palo Alto Networks, and they started with firewalls. Well, since then they have acquired many other capabilities, cloud-based offerings over the years, so they are trying to do a little bit of everything. So even though I talk about these 3 different categories, if you talk to a particular vendor, it could be a little bit confusing, right? Because they're going to try to say, we have this whole portfolio of all of these things that we will provide to you on a silver platter, right? So you've got to then decipher, make sense of what they're really offering. All right. Now, Cloud Security Alliance, right? Maybe some of you are familiar with them. They've been around for forever, right? They provide a lot of good guidance on cloud security best practices. Their version 4 of their cloud security guidance document is very good reading, especially for those of us starting our cloud journey that breaks up the cloud into these different domains, cloud computing concepts and architecture, like we've touched on so far here today, but also domain 2, governance and enterprise risk management, right, which is very important for thinking how this fits in to your overall risk management plan. Many other topics here, right, just as a reference for you to potentially check out. The cloud providers themselves also provide various well-architected frameworks. We've highlighted here just the security pillar of the well-architected framework here on this slide with some best practices. They've also got their various cloud adoption frameworks, because we know that the goal of the cloud providers is to not just provide us the best security, but their goal is to make as much money as possible, right? Charge us as much money as possible over time. All right, this brings us to our very last topic here, which is on detection. Now, I think hopefully you're familiar with MITRE ATT&CK, right? The de facto threat framework that is in use by hopefully all of our teams across the industry. But MITRE has also published MITRE ATT&CK for cloud, right? And MITRE publishes these different matrices, like we see here, based on real-world adversary activity, right? What tactics and techniques are attackers using? And the cool thing is, if you squint and look at this, now you can't see this from the back, but there are many different techniques, right, that are cloud-specific, right? That are cloud-specific. The ultimate outcome is the same, like persistence, lateral movement, data exfiltration, and so on, but the specific details might be a little bit different. And if we tie this back to the CIS benchmarks, the assessment configuration best practice, CIS at the top might say, as Miguel mentioned at the very beginning, MFA. You need to require MFA. But the cloud providers themselves also have their specific guidance. The good news is it's all the same at a high level. It all maps to each other. Azure's has theirs, AWS has theirs, but why? You do all of these things to mitigate, for example, a brute force attack, right? But even though at a high level these are all the same, as I mentioned, it's important to keep in mind that conceptually it's the same, but the way that the cloud works is different. So there's various details that your teams, your engineers, you as security professionals have to be familiar with in terms of what you actually need to look for, configure, protect, and correspondingly detect. From a detection perspective, the cloud providers all have some sort of out-of-the-box threat detection capability. Now, to be honest, these are constantly evolving. Some we might say is a little bit more basic, right, in terms of versus what you might have in your traditional SOC, right, they've been doing for a number of years. But the fact is that some of the common things that occur, right, these threat detection services could find them, whether that be in GuardDuty, Microsoft's Defender for Cloud, which one thing I don't like about Microsoft is that they seemingly change the names of their products every year, and I can't keep up. I don't know what product is what. On the far right-hand side, Google has a sensitive actions feature in their security operations tool set that was formerly known as, oh shoot, the name is escaping me. I'll remember it a little bit later, but it came through acquisition. Right? So if you enable one of these, if we tie this back all the way back to what we first talked about, the Capital One attack. Right? You remember how the Capital One attack happened? Well, the attacker, Paige Thompson, leveraged a application vulnerability, SSRF, to steal the credentials, configure her machine from wherever she was in the world, to then act as if she was the AWS server, but she's not within AWS. So this GuardDuty detection at the top says, hey, is there access coming from outside AWS that shouldn't normally occur, right? So then this gets kicked off, then it ties it back to the specific API call that was made, AWS S3 Sync, to download all of those, right, based upon those corresponding credentials. And oh, by the way, where was the attacker, right, in the world? Where did this anomalous activity actually come from? And what was the corresponding credentials down at the bottom? This detection, when the Capital One attack happened, didn't exist out of the box back then, right? So now we can see how these services are getting better, evolving, right, improving over time. Not perfect, right, but still, hey, it gets us a lot of the way there. All right, now in terms of getting this information from an overall detection perspective, it's not just about detecting, and what we've highlighted here are the different types of services in AWS and Azure in particular that could be used to detect stuff. But nowadays, hey, we don't just store the stuff in the cloud. Every SOC is having a little bit of a challenge right now. The SOC is in a transitionary period because previously we wanted to what? Centralize a lot of our alerts in the SIEM. And that's great. Now we get alerted. Your analyst gets alerted to something. But now, to do deeper investigation, depending on where you're deployed, they've got to go a little bit into maybe AWS. Now you need to log into Azure. You need to go into Sentinel. You need to go someplace else, right? Maybe you need to go look at the EDR logs and so on, because you can't put everything in the SIEM. So in some cases, though, you do need to send some of that log information someplace else. Now, maybe it's your SIEM, maybe it's your data lake, right, for example. And then eventually you're going to respond, right? Now this response might be a little bit manual to kick off your IR processes, or as we're going to see in the session after the break, right? Hey, you could potentially automate some of the response with something like your serverless functions, AWS Lambda or Azure functions, and so on. All right. So just in summary, what does this actually look like? Tying it back to what we saw with Capital One at the very top. Right? At the very beginning, we mentioned, hey, the user in the middle here, well, what do they want to do? All they want to do is download their PDFs of their monthly statement that they get from the corresponding S3 buckets. But the attacker, well, got that extra access. So she calls list buckets here. Then the catch is list buckets, it automatically, any AWS activity automatically generates a CloudTrail log. Now, there's some nuances that we could talk about the configuration, which management events versus other types of events that are automatically logged, or do you have to enable? Point being, hey, these logs are automatically generated, and then you've got a corresponding activity that occurs in the upper right-hand corner, but via an event bridge, right, Amazon's relaying service is sent back to a serverless function, Lambda, to then kick off some action to potentially, right, block access from that particular IP address here at the lower left-hand corner. And so this is an example of the types of things that you could do. Not just detect, but relay the information and respond to that particular activity. So before we open it up to any potential questions, just in summary here, what did we talk about? 5 different things. Number 1, we saw an example of identity via the instance metadata service and how you get those automatic credentials. Just one example of a cloud-native way that identity is provided. Number 2, architecture, having the right organizational structure, service control policies, having the right account structure from the start, automating the deployment of your infrastructure and applications, and how to inject security in the automated steps of that process, assessment, right, using the benchmarks and some tools, and then finally, being able to detect, right, being able to detect any potentially anomalous activity. With that, I'm going to go ahead and pause now. Any questions, comments before we take our break? All right. Well,
in this case, if you don't have any questions, at any rate, if you don't want to ask them right now, Frank is still going to be here for today, so don't hesitate to talk to him outside. Just bear in mind also, for those who are online, we're going to have a second session with Frank. So he's been showing us all the important part, but one really interesting element is automation. So the next part of his talk will be specifically on automation. If you're following online, you will see that there is a session that's called Cloud Automation, and you want to log into that one, because the one we're currently in will be closed. It's just a feature in Zoom that we're using. So make sure to log onto that one. And we're going to be reconvening at 11 a.m. So in the meantime, there are drinks outside. If you want to take a break, take a breather, that's the moment. If you just want to chat to Frank, that's also a possibility. See you later at 11 a.m.